Hello everybody, I will start my today with another coding practice. So in this video, I will solve the question, maximize distance to closest person. Yep. So in this question, I'm giving an array representing a row of seed where seed I is equal to 1, represent the person sitting in I seed, and seed if the index is 0, the seed at index is 0, it represents that the seat is empty. So there is at least one empty seat and at least one person sitting. So the ranks of the seat should be at least 2. Okay. And Alex wanna sit in the seat such that the distance between him and the closest person to him is maximized. Yep. Return the maximum distance to the closest person. I see. Mm. Okay. So in this question, I'm giving an array of integers, and each element in this seed list is 0 or 1. And 1 represents that someone is sitting in the I seat, and if it is 0, it means that the seat is empty. And Alex it sits somewhere in the empty seat. Yeah, it doesn't say he sit on the empty seat, but yeah, definitely he should, get seated on the empty seat. Yep. So, and my task is to find the seat whose distance to the closest person is minimized. No, sorry, maximized. Yeah, because he tried to have more space around him. Okay, so let me think of this question with, okay, oh, sorry. And my task is to return the maximum distance, not the index of the seat. Alex should. Okay. So let me think, for example, like this. So in this case, Alex can sit here. In that case, and the distance should be 1. No, yeah, 1. And if he sit here, the maximum distance should be 1, 2, 3, 4. Oh, yeah. And yeah, because one thing I can say is about the question statement is that there is at least one empty seat, so Alex can sit anywhere. And also because there is at least one person who's sitting in the list, so yeah, the distance from Alex to someone exists every time, always. Yeah. Oh, by the way, Alex can sit here, so I skip it. Yeah, and here the maximum distance should be 1 or 1 to 3, so it should be 3. And then when Alex sit here, the maximum distance is 2 or 2, which is 2. And when Alex sit here, the maximum distance should be 3 or 1. It should be 3. Yep. So in this way, I return. No, sorry, I did something wrong. So here, the maximum distance to the closest person is 1, and this is 2, and this is 1. Yep. So I should return 2. Okay. I see. So yeah, I think the brute force approach for this question is try to seed every seed, and from that seed, count the distance until the closest person, so the right word and left word. Yeah. So in this way, I can find the minimum distance to the closest person. Distance to the closest person. Then for each seed, I calculate this. For each empty seat, I calculate this and I return the maximum one. Yeah, among all of them. And this takes n squared time. Yeah, because I take a look at every seat, there n seat. Yeah. And from each seat, I go rightward and leftward with the pointer. So, and in the worst case, let's think that someone is sitting on the edge, left edge and right edge. In that case, from each seat, I have to traverse until the edge of the edges of the seat wrist. So it takes n time. So multiplying them, I get n squared. Yep. But yeah. Oh, but space is one constant. But I think I can, optimize this solution by with the prefix or suffix, array. Yeah. So the prefix array I would think is I would say distance from the closest person. Oh, let me say. I would think of the first array, the distance from the rest person. Yeah. For example, this, there isn't any person, so distance from the rest person should be, I would say this is infinity. Yeah. And for this seat, I don't have to think of it because it knows the empty seat. I just keep it. And for this, it should be 1, this, then 2, 3, and then I skip this. Okay. And next, I will think of the another array I will pre-build, which should be the list of distance from the right person. Yeah. Sorry. So to build this array, I traverse from the rightward. And for example, this, I skip it. But here, this should be 1, then this should be 2, and this should be 3, and this should be skipped, and then this should be 1. Okay. So now I've got the distance from the left person and right person. So for each, I will, many of these two arrays for each position. Yeah. Then I get 1 skip, then 1, 2, 1 skip. Yeah. So I return 2 in the end. Yeah. So this is the approach I've just come up with. Okay. So in this way, the time complexity should be O of n. Basically, I did 3 paths. So first traversal is building the list of first array, and the second traversal is to build the second array, and the third traversal is to get the mini for each position. They should O of n in total. And for space complexity, this should be O of n, obviously, because I built 2 pre-built, arrays. Yeah. So it takes O of n plus O of n is O of n. Yeah. So that's the space complexity. Okay. So now, yep, I'm pretty sure how I can solve this question. So I, start the implementation. Okay. Then um okay, so this is it. So yeah, in line 32 and 33, I pre-built two arrays, and in line 37, I take a look at each position, and I calculate the distance until the closest person by getting the mini of the corresponding element in each of these two arrays, and I compare them and then get the minimum one. Then I update the max distance with that, you know, distance till the closest person. Then I finally return the max. Okay. So now I will implement some methods. So for the build distance until left person, as oh wait, let me start with right one. No. Oh, sorry. It's okay. Yeah. Let me start with the left person one. Okay. I traverse until index 0 to n. Okay. Then I get last person index. I will think of this from minus infinity. So let me go with this. Okay. No. So if someone is sitting on this seat, I will just update last person index with this. And that's it. Otherwise, this is empty seat. So I calculate the distance until the left person. Yep. So it should be, yep, this. Yeah. Then, oh, I fill in the array, return the array with this. Okay, like this. Yeah. Okay, so now I return the array. Okay. So in this way, until the first person is found for the empty seat, because last person index is minus infinity, it becomes infinity, which is as expected. Okay. And for the, I mean, index whose seat is, yeah, occupied, um, you know, that position is still known. That is also expected because it skipped. Yeah. I mean, in the main method in line 38, I skipped that seat, so I don't have to take care of it. Yep. And for the seat which is occupied, not empty after some person, at least one person found, I calculate the distance with the gap between the current index and last person's index. Yep. Okay, good. And for distance there's the right person, I can do a bit of technique. So basically, I reverse the given seat first, and then I get the distance to the left person. Then I reverse the result and return it. So let me quickly write it down. Oh, actually, I can just reverse it. Yep, I can mutate this array because this is newly created in the build distance until left person method. Okay. Let me say this is read. Okay, so what I did is firstly I reversed the other, yeah, array as I said. So let me think how it works. So for example, if I get 0, 1, 0, 0, 1, yep. Firstly I reverse it like this. Then I guess the distance until the left person. So it should be like this. Then I reverse it in the end. So it becomes 1, no, 2, 1, and infinity. Yeah. So I can confirm that this is correct, obviously. Yeah. Okay, so I finished the implementation. So let me walk through my code with some example. I will make it very simple example like this. Yep. So in this case, I build distance until the left person. So here in line 48, read is initiative is nom 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 no no. Yep. Then in line 53, last person index is now minus infinity. Yep. Then in line 55, I traverse each position with index I, and if seed I is equal to 1, like here, oh no, if it is 1, I skip it. No, so I don't skip it. I just update the last person index. But this time this is 0, so I go to line 60, and distance is 0 minus infinity is now infinity. Yep. So this is updated with infinity. Okay. Now I go to index 1, which is value 1. So in line 57, this is true. So I get in line 58, last person index is now 1. Yeah. Then I go to index 2 and seed I is equal to 0. I go to line 60 and distance is now 2 minus 1 is 1. So yeah, this becomes 1. Then in next, I get 0 again. So in line 56 back again, and I get distance is equal to 3 minus 1 is 2. So I updated the array. Then I get for next index, I get 1. So last person index is updated with 1, 2, 3, 4. Yeah, in vain. Yeah, and I return this 0, 1, 0, 0, 1. Yeah, yeah, to the, oh, sorry, this one. Infinity num 1 to num to the main method. And in line 39, I calculate distance until the right person. So I'm pretty sure this method is correct because I already checked it. I will use this result. Okay, so now I go to line 42 and max distance begins with minus infinity. And for each index, if city is 1, I skip it. And otherwise, I guess the distance until closest person by the meaning of them. Yeah. So first 3, infinity and 1. In this case, this is 1. And max distance is now becomes 1. And yep. Okay. Then for index, for index 1, I skip it because seed I is 1. Then next, I compare 1 and 2 and I get mini 1. So max distance is still 1. Yep. And then next, oh, actually this example is maybe not good because, yeah, minimum distance and minimum distance is in the end 1. But that's okay. Yeah, for index 3, I compare 1 and 2 and I get distance till closest person to be 1. So this, I update max distance with this and I max distance is 1. Okay. And then I move the pointer again. And now this is 1. So in line 46 is true. So I go to line 48 and continue. And it's the end of the iteration. So I get max distance 1. Okay. Yep. So now I've covered all the lines in my implementation. So I'm pretty confident on my code. So I run I run it. Good. And I submit it. Okay, accepted. Great. So let me quickly wrap up my today's coding practice. So today I solved the question, maximum distance to closest person. In this question, I'm giving an array of integers. And for each cell in the, each element in the seed is 0 or 1. 0 represents that there is no one sitting on that index, and 1 represents that someone is sitting there. And I traverse from index 0. And Alex would like to sit somewhere. Alex would like to somewhere on the empty seat. And he'd like to, be distant from the surrounding person as much as possible. So my task is to find the good position for Alex so that Alex, the distance until the closest person is maximized. Yeah. And I return that maximized distance. And for my solution, I basically use the rebuild two arrays. Yeah. The first one is distance until the left person, and the second one is distance until the right person. Yeah. Once I calculate them, I traverse the array again, and for the empty seat, I take a look at the left, distance until the left person, distance until the right person, and I get the meaning of them. So that's the distance until the closest person in each seat. So in the end, I return the maximum one of these distances for each cell. Okay, this is it. So I finished my test coding practice with this. Thank you so much. Bye.